Hi, my name is Fletcher Levy, and today we'll be doing the chemical equilibrium question 16.6. This question states that methane gas reacts with molecular iodine gas to produce hydrogen iodide gas and gaseous iodomethane, CH3I, in a reversible reaction. At 630 degrees Kelvin, the Kp is equivalent to 2.26 times 10 to the negative 4. If the initial partial pressure of methane is 105.11 torr and iodide is 7.96 torr, we are asked to calculate the equilibrium pressure of products and reactants for this reaction. So, with this information, we know that we are given an initial partial pressure for the reagents, a reaction that we have to write out, and we asked to calculate equilibrium pressure. So we know that this is a Rice table equation. So we'll be needing to work on our Rice table. Alright, so now that we know that we're calculating for the partial pressure equilibrium, first thing we have to do is write out the balanced chemical equation. CH4 methane plus iodine gas I2 in a reversible reaction forms hydrogen iodide HI plus CH3I, which we're given. This is already balanced. As you can see, carbon, 4 hydrogen, 1, 2, 3, 4, and 2 iodine on either side. So that's great. We don't have to do any more stoichiometric coefficients. The initial partial pressure for CH4, 105.1, for iodine, 7.96, 0 for both of the products. And now for the change, we're losing 1 mole of reactant, losing another mole of reactant, adding 1 mole product, 1 mole product. So the equilibrium pressure is the initial minus 1x for the reactants, and for the products it's 0 plus x for the partial pressure equilibrium. So now we have these values, we're going to plug those in and solve for x. Now since we know the equilibrium is equivalent, we have one variable x, we're going to be solving for x. We can put this into an equation, Kp equals products over reactants, partial pressure products, partial pressure reactants. We know our Kp for this reaction is 2.26 times 10 to the negative 4. We know that our products equilibrium partial pressure is x for both cases, so x times x squared, and equilibrium for the reactants 105.1 minus x times 7.96 minus x, and we are going to be solving for x, so what we're going to have to do is FOIL these two and set the equation equal to 0, and then use the quadratic formula to solve for x, which we will then subtract from the initial to solve for the final or equilibrium partial pressures. Now that we have our equilibrium partial pressure equation, we are going to set this equation equal to 0 so we can plug that into the quadratic formula. We have 2.226 times 10 to the negative 4th equals x squared over 105.1 minus x times 7.96 minus x. We're going to FOIL this bottom part of the equation and get 836.6 x squared, and if we add these two values together we get 113.06, so we can plug that in on the bottom here, and that still is equal to 2.226 times 10 to the negative 4th. So if we want to set that equal to 0, we're going to have to multiply by 2.226 times 10 to the negative 4th. In order to isolate x squared, we get 2.226 times 10 to the negative 4th x squared. We multiply these two together, negative 2.55 times 10 to the negative 4th x, and 836.6 times 2.226 times 10 to the negative 4th is 0.1891, and that's all on one side, and x squared is on one side. So now what we want to do is we're going to subtract x squared from both sides, and this only changes this x squared value. So if we subtract 2.226 times 10 to the negative 4th x squared, it's a very small number. If we subtract 1, basically, we're going to have a negative 1 almost x squared. And now, which finally in ax squared plus bx plus c format equals 0, now we can plug negative 0.999 x squared minus 2.55 times 10 to the negative 4th plus 0.1891 into the quadratic formula to solve for x. Alright, with our ax squared plus bx plus c format equals 0, we can plug that into the quadratic equation and get 0.0255 plus or minus the square root of 0.255 squared minus 4 times 0.999 times 0.1891 over 2 times negative 0.99. Alright, and we can simplify this. If we square that, we get 6.53 times 10 to the negative 4th. We multiply all these together, we get 0.7556. If we multiply 2 times negative 0.999, we get negative 1.998. And if we add these two values together, we get 0.756. We take the square root of 0.756, we get 0.87. And now is the crucial part where we add and subtract 0.87. If we add 0.87 to this equation, we get negative 0.448. If we were to subtract 0.87, we get positive 0.424. And since we can't have a negative value in this instance, we know that our positive value, 0.424, is correct. Now that we have that x equals 0.424, we can plug that into a rice table in which we have the initial minus x. 105.1 torr minus 0.424 is 104.7 torr for methane. Iodine is 7.96 minus 0.424, 7.53 torr for iodine. Hydrogen iodide, 0 plus 0.424, 0.424, and the same is true for CH3I. So here are our equilibrium pressures, and we can double check that these are correct because we'd expect that less product, very small product, over more reactant. These reactants don't really change. 105 versus 104, both pretty large. 7.96 versus 7.53, still pretty large. We would expect small product over large reactant, small Kp, which is what we have, 2.26 times 10 to the negative fourth. It's a pretty small number, so we know our values seem right.